When you study fluid mechanics, there are a number of different ways that you can analyze the flow. And so what we're going to do in this segment is we're going to briefly talk about the different flow analysis techniques that we'll be covering in this course. So the three main flow analysis techniques that we're going to be looking at, we'll be looking at control volume analysis, we'll be looking at infinitesimal systems, so basically differential equations describing fluid flow. And we'll be looking at methods for doing experiments. So those are the three main techniques that we're going to be reviewing in the course. Now, control volume is sometimes also called integral analysis. And this is a crude but quick tool. It will not give you velocity profiles, but it will give you forces, things like that. You can calculate mass flow rate and generic forces that might be on a body or on a plate or a wall. It's good for a preliminary study. And it yields reliable quantitative information. So that is control volume analysis. Infinitesimal systems, this could also be referred to as being differential analysis. And for this, what we're going to do, we're going to derive governing equations for fluid mechanics, starting with a little chunk of mass. And we'll end up with differential equations, partial differential equations. And there are a limited number of analytical solutions to these equations. If the flow is treated as being inviscid, it would be the Euler equation that you end up with. And if the flow is viscous, with viscosity, it would be the Navier-Stokes equations. But there are only a limited number of analytical solutions. And this technique in recent years has formed the basis of a lot of the computational fluid dynamics software systems. So the differential analysis now forms the basis of CFD. And for this, the equations of motion, or the differential equations, are solved using numerical methods on computers. Now, the last area is experimental study, and we'll be looking at this as well. And typically, or for the most part, what we'll be examining is dimensional analysis. And so this is what experimentalists do prior to conducting an experiment. And the need for experiments, sometimes situations or scenarios are so complex that numerical methods are not adequate. Quite often, if you have turbulent flow, large scales, you still do need to conduct experiments in order to fully understand what is going on within a system. And this is for complex problems. And quite often, most often, these are subscale of full-scale systems. And consequently, that's why we perform the dimensional analysis. It's to understand if you're studying something at reduced scale or subscale, how does that then scale to the real world type system? So those are the three main analysis techniques that we'll be covering in this course: control volume analysis, infinitesimal systems or differential analysis, the Euler and Navier-Stokes equation, and then experimental dimensional analysis, and that will be the Buckingham pi. Control volume will be looking at the mass conservation as well as the momentum equation. We'll talk a little bit about the energy equation. That's more what you would find in a course on thermodynamics, and so we'll mainly look at mass and momentum in this course. So those are the flow analysis techniques that we will be looking at within this course.